Well, of course, the first answer to that is, where do you want to build your lighthouse? Now, the interesting thing is, most of lighthouse engineering technology begins in Europe. That's modern lighthouses. And European coasts are in general quite rocky. And the places that were dangerous, where you wanted to put a light, were usually low rocks out in the sea, so very, very exposed. And you need to put a light onto a low rock, which maybe when the tide is high, is underwater. So that means that anything, when you've got a really big storm at sea, huge waves, this has to be very strong. And the only technology that was available, because we're looking at the end of the 18th century, the only technology that was available is stone or bricks. Bricks, difficult, because that relies on how strongly cement can hold. So they started to use stone, but to make sure the stone was strong enough, they couldn't just take a stone, put it down, then put another stone on top with mortar, then another stone on top of that. Because when you join stones that way, the join is only as strong as the glue that you put between. So it's just a cement join. And they realized very quickly that that wasn't strong enough. So what they began to work out was a way of building lighthouses with stone, like you make a jigsaw. You know jigsaw puzzles where you get bits of cardboard cut out and they have shapes and it locks in like Lego. And so they built lighthouses like stone Lego, only they would have a slot and it would be a dovetail slot and two stones would slide together and lock solid. And this one would slide into the side of that one and lock solid. So the whole lighthouse would be locked to itself as you built it, so it just became a single unit. They also realized that when waves break, they break with huge force, 29, 30 tons a square meter. So that's like driving a car at full speed into a wall. So massive bang. And they worked out that the best way to combat nature is to give a little. And so what they did with the towers is they worked out that a hyperbole section, so that's one shape like this, that was also round, would break the waves, like the front of a ship. So when a wave came bashing into it, the wave would divide around it, and its force would be absorbed. And that way they made a strong structure, stones locked into each other, and then they managed to make the waves break around it so that the tower would stand there. They also had to make sure that the tower was tall enough, because in a really big storm, probably the tallest wave that has ever been recorded is somewhere around about 30 meters high. And when it breaks, it hits something, and more of it shoots up in the air. And there are stories. Here in Hong Kong, the very south of Hong Kong, we've got a lighthouse called Waglan Light. And Waglan Light Tower is about 20 meters tall. And it sits on top of an island that is about 50 meters tall. So altogether, 70, 80 meters above the surface of the sea. In a typhoon, the waves were picking up stones from the bottom of the sea, which is 20 meters down, and throwing them on the lantern of the lighthouse, 70 meters above the sea, and breaking glass. So it's that power that you have to remember that the sea can create. So these lighthouses they built on the offshore islands, some of them are 60 meters tall, 70 meters tall, beautiful, great, tall, slender towers of enormous strength. Very, very beautiful. So that's the first one. They're made out of stone. But that's assuming that you've got nice, solid stone to lock your lighthouse tower to. So there's another problem. You've got your really strong tower. All the stones are locked tightly to each other. It's exactly the right shape. But your major problem is, this is what it's sitting on. How do you make sure you don't push it off? Many of the very early lighthouses, they just disappeared. because they just got pushed right off the rock and disappeared into the water. So the next problem is locking it hard to what you're building it on. With stone, that's not difficult. You can cut a big opening and you can bind the stones into the opening, and that then effectively makes sure the lighthouse is properly anchored. But what if you don't have stone? What if you've got sand or mud? In the early days, there was not a lot they could do with that. The first solution was basically how we build tall buildings in Hong Kong. You've got a big cylinder which you stick down into the water onto the sand below. Then you put somebody inside the cylinder and they start digging out the sand. And the sand goes out and the cylinder sinks down into the seabed.
It's a screw house.
No, this is what's called a caisson, C-A-I-S-S-O-N.
Some caissons.
Yeah, caissons. And this is how they used to build bridges. In order to put the piles of bridges in, they would dig them in the same way into a riverbed. And somebody worked out you could do that with lighthouses. So they would dig these big cylinders into the seabed and then put the lighthouse on top. So that's one solution. The trouble with that is you've got to be sure the seabed doesn't move. Now the interesting thing is seabeds do move, particularly in places like the Malacca Strait or in the southern end of the Taiwan Strait. You get phenomena which are called sand waves. You get it in the English Channel as well. And the seabed moves. It doesn't move very, very fast, but it does move. So over a period of like 10 or 20 years, what was here may have moved 50, 60, 100 meters this way. So obviously if you've got a caisson, it's going to move too. So your lighthouse isn't going to be in the same place. Worse, it doesn't all move at the same speed. So the top sand is moving faster than the sand 5 meters down. And that's moving faster than the sand 5 meters below that. And the sand 5 meters below that doesn't move at all. So your caisson is actually beginning to fall over as the sand moves. So you've got to try and think up another route. And this emerges sometime in the 1860s, which is this screw pile. And that's exactly what it says. You've got this big, long steel pile, and on the bottom, it's got an enormous screw. And you just turn it. And you keep turning it, and it buries its way down into the seabed. And it can go a long way down. Some of the screw pile lighthouses are maybe, their screw pile is 15, 20 meters below the seabed. And once you've got your screw piles in there, then you can join them all up at the top with nice lattice frameworks, and then stick a platform on top, which has got your lighthouse. That has the advantage, when we're going back to the problem of big crashing waves, is with a lattice framework, it's open. So waves break through it, as opposed to trying to break onto it. So then you've solved two problems again, by having something that absorbs the force of the waves, and something that's strong enough to stand high above the surface of the sea.
I found that lighthouses are usually hyperbolic cylinder. Do they have any other shapes?
Well, obviously your real problem is if you can't put a lighthouse somewhere because either you don't have the technology or because you can't fix something. Now let me explain. In China, the Great Yangtze River comes flowing out into the China Sea, carrying an enormous amount of mud. It's basically taking Sichuan province and bringing it to Taiwan, grain by grain by grain. So it's wearing the mountains down and carrying them to the sea. And when it gets to the Yangtze estuary, where it flows out into the sea, it slows down, and when water slows, it drops what it's carrying, which is silt. And so the mouth of the Yangtze River is full of sandbars. But these sandbars move all the time. If you have a sudden flood, the river may change course and carve a new channel, and the lights you put there last week now don't show the right way. And it's very expensive to build a lighthouse and then 2 years later destroy it and build it somewhere else. So the solution, which the first example that we've got a record of is in Europe in about 1750. Somebody thought, well, why don't we just anchor a ship and put a light on a ship? So that's what they did. To begin with, they would just find old ships that nobody had any use for, and they'd just hang a light in one of the masts, and they would anchor it in position, and that would be the lighthouse. And if they needed to move it, just take the anchors up, move it, put the anchors down again, and you've got this moving light. So some of the early lights in China, one of the very earliest, was a light ship moored in the entrance to the Yangtze River in, I think it was 1872, 73. One of the earliest lights, the Tongsha light, East Sand, was one of the earliest light ships in China. So that's another route. And gradually, they started to build these purpose-built, because obviously you've got a light ship there, and it's anchored. A big storm comes along, and anchors can break. So they refine them, they get more and more anchors. Most light ships are anchored with 4 anchors, so that they don't move. The whole point about a light beam, it's in one position. But a ship on an anchor, if it's just got one anchor, it goes this way, with the wind is blowing from here, and if the wind changes round, it comes back here. And it may be moving through a circle of 400 meters, 500 meters, which is navigationally not very good. So they want to fix it in place, and you have to have stronger and stronger anchors. But again, this is another technological thing, that during the course, whilst all of this is developing, everything is developing. I was saying when last we were talking how the optics of lighthouses and the structures of everything was changing. Fuel, optics, it was all changing at once. Well, likewise with light ships, the technology of building them, they go from being wood to going to iron, to going to steel, from being riveted steel to welded steel. They get 2 anchors, 4 anchors, and the anchors themselves develop so that as opposed to holding just because they're heavy, they start to have refined designs that help them dig in like a plough, ploughing a field. They dig further and further into the mud, and the more pull you pull on them, the deeper they go, so the more secure you are.
I think there must be someone who had made great contributions to the engineering of lighthouse. So could you please name them one of 2?
Golly, naming, and I haven't done my homework well enough. The most famous, probably of them all, is one family from Scotland called the Stephensons, who were the great lighthouse engineers of the middle 19th century. They designed and built all the most famous and beautiful British lighthouses in the most remote places. They supervised the building of these complex towers with their interlocking stones. They also worked on the light technology, on the optics. They worked on all aspects. And they weren't just lighthouse designers either. They also were port engineers. So they developed sea walls, like typhoon shelter walls. They built and designed piers. They were just generally extremely good civil engineers working in the marine sector. And lighthouses were one of their contributions. And then actually, no, they're so famous because it was 3 generations were in the lighthouse designing business, from the very first in the early 19th century to the very last in the 1870s and 1880s. So it's grandfather, father, son. All 3 of them were in the lighthouse business. Before then, there was a famous Englishman called John Smeaton, and he's famous for having built the first of these hyperbolic shaped towers with interlocking stones. And that lighthouse, which he put on a remote rock right out the middle of the English Channel, when it was replaced in the late 19th century, replaced in the 1880s, the old lighthouse was taken down and re-erected in the English town of Plymouth, and you can go and see it today. It's still there. So it was, you see, it really is such a monument in the world of lighthouse engineering. The Stephensons, they consulted all over the world. There are Stephenson lighthouses, ones where the Stephensons have consulted in Japan, China, not in Hong Kong, as far as I know. There are no Stephenson lighthouses here. There was a French company called Barbier, Benard, and Fenest, who were very big in lighthouse engineering in the late 19th century, 1880s and 1890s. And a lot of China's lights were made by Barbier, Benard and Fenestre. So, including Wagram Light and its sister, the Tien light in Liaodong. They were both made by this big French company. A lot of the lights in the Middle East are also made by the French. There's a man whose name I cannot remember, who is the father of the screw pile, who built his first one on some sandbanks in east of England, in Essex. And he was very popular, his design was very popular, built a lot of lights on the east coast of the United States of America, where it's all very sandy and very shallow, and there aren't good firm rocks to build lighthouses on. But in the end, I mean, lighthouse engineers, there are so many by the time you've worked it all out, that only one or two really stand out, and the Stevensons are probably there.
Okay, that's all.
That's it?
That's it? Okay.